What's happening, guys? Scott from Hornet's Nest. Welcome back to episode 28 of Tutorial Tuesday. As always, so good to see you. And in today's episode, I want to show you this. It's the standby instrument cluster located just above the pilot's right knee in the F-18 Hornet. And it's taken a while to build it. We've gone through getting the wrong parts, getting the wrong parts sent to me again, getting the wrong parts sent once more, eventually getting the right parts, then breaking a circuit board, waiting for new circuit boards to arrive, and then soldering them the wrong way. So we've gone through a process, and it was going to be a step-by-step tutorial of how to build this, but now it's more going to be a don't be like Scott tutorial. And I'm going to teach you the tips and tricks that I learned along the way so you can have a pretty pain-free experience building this standby instrument module. So to kick it off, I want to show you how to build these analog gauges, and I'm going to show you how to do it using the altimeter and the cabin press gauge. If you know how to build both of these, you're going to know how to build them all. So here we've got a sub-assembly of the altimeter. It's almost ready to be installed. And then we've got the broken up pieces of what the cabin press gauge is. It's made up of PCBs, steppers, LEDs, mounts, bezels, faces, hardware, needles, glass spacers, wiring. That's pretty much all you need for a gauge. And I'm going to show you how that all assembles and the order to put these things in, so you don't have to do repeat steps. So let's have a look at them. You're going to need 4 PCBs, you're going to need a standby controller, a standby altimeter, a couple analog instruments, and a couple photo utility switches. Now, I'm pretty fortunate. I get my circuit board sponsored to me from PCBWay. The standby controller you see in this episode was given to me by them. Not only do they do great PCBs, but their quality is amazing, their customer service is up there, and their speed of production is what really sells it for me. Yes, a little bit more expensive than other PCB houses, but those attributes alone is what justifies that price to me. As well as they do 3D printing, CNC milling, and laser cutting. That way, if you don't have any of those tools at home, you can just outsource straight to them. Now, these gauges, the analog and the photo utility switch, I actually was in a group buy for those, and the group buy uses the Open Hornet recommended manufacturer, so I was able to see different companies. And just a bit of a side note, just remember, Open Hornet does recommend a manufacturer because that's what they've exported it to. So yes, the PCBs at the moment work with PCBWay, but if you come into any issues, just know that Open Hornet has designed it specifically for a manufacturer, and I've been fortunate enough that they can cross-populate across the different companies. Then we go onto our steppers. This here looks like the VID29 called out by Open Hornet, but it's not. The VID2902P, it's a black stepper motor that drives needles, is going out of production. They're no longer making them. So to find them is going to be really, really tricky, or it's going to be terribly expensive. So you'll find a lot of companies on AliExpress selling the VID29, but they will send you something very different. And that's what happened to me. I tried 3 times, 3 different companies, 3 different websites trying to find VID29s, and they kept selling me a X27168. It's a white stepper motor. It's the same footprint as this. It's just a little bit taller in the body. It's not as thin. And when you've got a gauge that is so well built and compact as these, you really need that slim profile. So I was at a real loss. I couldn't find any of these, and this is where community kind of comes in. I was able to reach out to one of the members, Ben. You'll know him as Ben from F18 Sim, or Ben F111 on his GitHub. He was able to point me in a direction of saying, hey, these look pretty close, give these a go. And they were the BKA 30Fs, and I bought 10 of them, AliExpress, super cheap, and they work perfectly. They're a drop-in replica of the VID29. Now, stepper motors, especially like these type, only travel 315 degrees. Now we need 360 degrees, especially for the altimeter. So I followed Cricky's tutorial on Open Hornet. I'll drop a link in the description below for that. They're an Open Hornet dev, and they did a wonderful tutorial. I'm not even gonna try replicate it or even try to show you. Just go there. The pictures, the descriptions, everything is so simple to follow, and I'll leave it up to them. So I want to modify these. You're going to need to modify these for the VVI, the ASI, and the altimeter. And this one is a 315 normal stepper, which we'll be using for the cabin. We then go into the LEDs. These are the NeoPixel 5mm through-hole diffused individually addressable LEDs. Essentially, all it means is I can tell each individual LED what color I want it to be. They diffused and they go through the circuit board. They're not surface mounted. Now, these come in packs of 10. Fun fact, don't be like Scott here. I didn't read they come in packs of 10. I saw the price, I was like, it's an expensive LED, but sure, why not? It's individually addressable, RGB, diffused, through-hole mounted. I'll justify that price. And I went and put in, I think it was 12 I needed, 10 or 12. And I ended up getting 10 or 12 packets of 10. I have so many of these LEDs now, it's not even funny. I could start my own little warehouse. So when you order these, just make sure you register that it is a 10 pack. I think you only need 2 packets. Don't be like me and get 12 packets. Whilst this is getting ordered, go and order from Mouser or DigiKey at the same time your optical sensor. It's the OPB615, essentially an optical sensor, just as a switch that uses blocking of light to say if it's on or off. And we use that to help us tell the position of our modified stepper motors. The OPB615 is currently on back order. So if you want to be building this using the 615s, get onto it now, order now so they can come as soon as possible. I think Mouser was showing me around August, September. So about a month, 2-month wait time on those. Then we go and move to our displays. These are needed for the altimeter only. You need 2 of them. They cost about $2 each and I got them from Buy Display and I'll pop those links in the description below. And then we move on to the manufacturing of it all. So whilst everything is in the post coming towards us, let's start manufacturing. And that way, when it all arrives in the post, our manufacturing of these components should be done as well and we can assemble it in one hit. So 3 steps for the manufacturing. The first one is we're going to open up QIDI Studio. It's my favorite slicer because I pair it with the QIDI X4. Beautiful printer. The team at QIDI sent me that last year for one of the episodes. Chamber heating, massive build plate, heaps of filament options, wireless connection, really great printer for a pretty good price. So if you're looking for a printer and you're a bit brand saturated at the moment, you're not quite sure where to go, have a look at QIDI. There's a link in the description below. It helps me out and it tells them where you found them. But getting back into the slicer, you can see that with its large build plate, we were able to put everything onto 2 plates comfortably. I'm using PETG Pro from Alegu, 0.2mm layer heights, reasonable speeds, and we're looking at about a 9.5 hour print time. I generally run my prints overnight, so I don't care too much for the speed, because I find if I print a little bit slower, I don't have to spend as much time post-processing doing the filling, the sanding, the priming, the prepping and all that. Whilst we got this printed, I then moved across to Lightsheet and I dropped in all the knobs that we needed. I'm printing the knobs out of a mix that I made for most all my buttons. It's half white, half translucent. And again, I'm using ABS-like resin from Alegu, and that's on the Alegu Saturn II. With resin printing, on the basis that everything's the same height, and let's say we use 1 knob for example, I recommend printing multiples of what you need. 1, it's going to give you a fail-safe if one of the prints fail, but 2, it just gives you a spare. And the nice thing about resin printing is whether you print 1 knob or 20 knobs, it's going to take the same time because it's based off height, not quantity. So when we go do this, I definitely recommend, and I'll pop all these scenes in the package, print multiple. Give yourself a little bit of a fail-safe option. And whilst these were all going, I started prepping and priming and painting the acrylic that I was going to use for these gauge fronts. And I'm using my laser cutter to engrave and cut these faces and glass and needles out. So that is it there in a nutshell. It looks like a big process, but it's a fairly involved process, but it's just repetitive because there's so many gauges. Now, my recommendation is get everything ordered online first. That way you have a good time frame of when things are going to be arriving. Second, start the manufacturing. 3D printing is a must. You can always do gauge faces later, but the 3D printing of the mount and the bezels and the spaces and then your resin knobs is going to take you a bit of time. This is that prepping, priming, painting phase. It takes a good week or so. That way you're not rushing those paint layers and you'll get a really good finish. So let's get into the assembly of it. We're going to start off building up this cabin pressure gauge. We're going to start off on the PCB and we're going to solder in our jumper pins here. If you are installing the 3-pin connector for the zeroing unit, and you'd be doing that with your altimeter, ASI, and VVI, can I recommend, I'll put a picture of what the Open Hornet one looks like. It's got the pins vertically going up, standing next to the stepper motor. Instead, if we just have a look at the back of the altimeter here, I've gone and used the 90° on the reverse side. It just allows that cable to loop up and around and just nicely sit in there, and you don't have to solder into it. If you put those pins the way Open Hornet's got them, now maybe I'm wrong with this, I found I didn't have a lot of headroom to put the jumper in. So instead, 90° on the back, silicon wire, you're not gonna have any issues. And then we're gonna go grab our stepper motor and we're gonna install it onto the back of this gauge. And there is only one way that this can go in. And then you'll hear it click in, and then we are good to go. Now at this point, you can go and solder these 4 pins as well. For the purpose of this, I'm gonna leave it to the very end, because I'm gonna solder them when I solder the LEDs in. As simple as that, that's done. Let's go pop that to the side. The next thing we're gonna wanna do is grab our mount here. This is the same as the VVI, ASI cabin press. The altimeter one is a little bit different, but the concept is the same. We're gonna take our countersunk screws and we are gonna screw in the standoffs. There we go. And that's pretty much it done for this. If you were building the ASI, VVI, or altimeter, or anything with a zeroing meter, this is the time to install the optical sensor PCB to this little hole here first. My suggestion is tap that hole with your screw first, unscrew it, then put your PCB in. It will make your life a whole lot easier. But that's done there now. Let's go and grab our PCB. We want to go and thread in our LEDs. The problem with these LEDs are they, one, don't come out with a nice data sheet. There's nothing really written of what the pinout of these are. But the second thing is the Open Hornet silk screen is inversed. So I'm going to tell you the right way how to install these, because I installed these wrong the first way I did it. So if we're looking at the LED that we've got here now, the very left leg is a short leg compared to the 2 right ones. The first short leg goes into the left-hand PCB hole, and that is indicated by a square pad. And then that is the correct orientation. Do not try and install these to the silk screen, because you'd think, oh, the silk screen's got a flat edge, I'm gonna install the LED's flat edge to it. As of right now, which is July of 2025, the current PCBs available, the silk screen is wrong. Put the short leg in there like that. I'm not gonna solder those in. I'll solder them in at the very end, and the reason for that is these LEDs provide face lighting. It's not backlighting, it's where they shine actually on the face of the gauge, and we need to position them at the correct distance and height for that, and it's a whole lot easier to do that later down the track than trying to guess what it is now. So let's go grab this, pop these 2 pieces together, and then we are going to go and screw it in. There we go. And you can see now that these LEDs can move about. If you try to install them now, you're not going to be able to get them in. So that's why you have to install them before screwing it together. And then they will fall down nicely into that position. Now this is where, if you wanted to, you could go and solder them in now, but I'll solder them at the end of this video. Beautiful. We are pretty much up to similar steps now with our altimeter and our cabin press. We've got everything installed. Now we've got to calibrate the gauges. We've got a 360-degree stepper on the left. We've got a normal stepper on the right. Let's do this first one here with the cabin press. It's the simplest. If we bring up its face, we know that the needle is going to start at 0 feet and it will go clockwise to roughly around here. So to home that, when I want to home a stepper with a mechanical stop, we're just going to drive the needle until it hits its mechanical stop. We now know it's at the very beginning of its motion of travel. So we know the needle goes clockwise, so we're going to gently wind our stepper anti-clockwise till it hits its stop. That way we know it's at a known position. Now we are good to go and installing the face. But before we do this, let me show you how I created these needles. Let's load up into Lightburn, and I'm gonna open up to this file here. And I'll provide this file as well with all my settings, and you can tweak from that. In the work area, if we zoom in, we've got all the needles. We've got the altimeter, the cabin, the VVI, the ASI. These little paddle looking ones, they're gonna be optical sensor needles. And then these three at the top here are the assembly for the altimeter's version, just because of some spacing issues. Now, they're pretty thin, and I'm making these out of 0.8mm Romark, white Romark painted black. The thing with Romark, and especially being this thin, is they're pretty flimsy, and any heat applied to them is gonna cause them to warp. So one, how do we cut these nicely so we don't just blast it with energy? And two, how can we secure them to stop them warping? Let me show you. I'm gonna click on this top needle here, because it's our flimsiest one, and it has brown as the color. Remembering, if you're new to Lightburn, the color doesn't determine the power setting. The color is just a reference, and you can see here, this color is linked to a power and speed setting that I've chosen. So my brown may very well be different to your brown. So the brown here, we can double click on the layer info and it brings up the dialog or the settings editor. I want to do 2 passes of a reasonably quick and low power cut. I want to just scrape away at the Romark twice instead of just going one big cut first, because you're going to damage your needle that way. So number of passes is 2, and I've got the kerf offset to 0.2 outwards. Kerf, if you've done any form of woodwork, is just the thickness of a blade. A laser cutter is a blade essentially, and it's got thickness as well. Not as big as a 2mm thickness on a table saw, but it's got thickness. And I've measured mine is about 0.2mm. It's a good number. And what it's gonna do is, it's gonna offset the beam 0.2mm on the outside of our shape. And that's gonna keep its dimensional integrity, as well as just give it a little bit of thickness if you needed it to stop being so flimsy. And then you'll notice here, I've got these red dots everywhere, and these are called tabs. If I just go right click preview, this is gonna show me what the laser cutter is actually gonna do. I'm gonna show you what these tabs look like, and then I'm gonna show you how to make them. Let's zoom in here. You can see that the black line is where the laser cutter is gonna cut. It skips a little section, starts cutting some more, skips a little section, cuts some more, skips a little section. The tab is keeping it to the base material. It's keeping it secure. It's not going to allow it to warp. As well as, let me show you a little video of me painting these. Painting these connected to tabs is so much easier than trying to get tweezers and holding these tiny little needles. So that's the tabs. How do we create them? Well, we're going to go select a shape. We're going to go to our left-hand menu here, and we're going to go add tabs. And guess what? Its shortcut is Control or Command Tab. We're going to click that, and then we're going to click anywhere we want. Now, if you want to delete a tab, hold Shift and click the tabs you want to delete. That is how you create tabs. That is how you adjust the kerf. That is how you create multiple passes. That's the little tips and tricks for these. The last thing is, I want to show you that the interior holes that connect onto the shaft are a different color. I'm still cutting. We look at our panel here, it's still the same speed, it's still the same power. We'll open it up, it's still 2 passes, but I just don't have a kerf offset. The reason for that is, I actually want these holes to be cut smaller than they're intended to be. That way I can manually drill them out with some precision little drill bits here, and I can really dictate that size. It would be a nightmare trying to calibrate my laser to cut at the exact diameter. I'd rather just step it up in drill bits till I find one that presses snugly onto the shaft. So that's that done. Let's go and grab our needle here, and I'm gonna grab this little drill bit, and you can see that I'm going to just drill out that hole. There we go. Nice. With our gauge zeroed again, we went anti-clockwise, nice and gently. We're going to press the face down as nicely as we can. We're going to align it as best as we can. We're going to just eyeball it. It's pretty good. I think maybe there could be an easier way. The best way is if you've got a vertical line on the top, just align it with that top screw. That's good there. And now we're going to grab our needle and we're just going to press it on. Like that. That is it. That is as simple as it gets. The next thing we're going to want to do is grab our bezel, flip it upside down. We're going to want to grab our glass and then we're going to peel its backing off. And this is why I use gloves as well. It stops you getting fingerprints on this. There we go. We're going to take off any residue that we can see. And we're going to install it in there. Now this is where the gymnastics of it comes in. So you want to go and grab your spacer and place it there with the access holes facing up so you get a nice clean area where your LED is going to shine through. And now you're going to want to join these like a sandwich together. Our needle is fixed. It's fixed to the gauge. So if our little face moves around a bit, it's not too much of an issue. What we're going to want to do is grab these two and carefully place them in together. There we go, give it a bit of a percussive maintenance. And there, we got it. Look at that. That looks quite nice. And that's all nice and centered. And you can see that zeroing of that needle is pretty close. Cool. There we go. There's that one done. Let's actually move this off camera and we'll just keep that one nice and safe. And that's going to get installed later down the track. Now, time to move on to the calibration of a 360 degree with an optical sensor. The thing with these is how do we, one, know how many steps it takes to go per revolution? How do we know when it triggers? Well, let's go and do all this by running a little bit of code that I wrote. What we're going to do is let's pull up our Arduino IDE. Now this here is, I'm going to give you this file as well. It's called the Open Hornet Gauge Calibration, and it's really designed just for the standby module. It's where we're going to go and count how many steps it takes one of these modified steppers to go and do 360 degrees, as well as it's going to hard lock it at that homing point to allow us to fit that needle, as well as it's going to allow us to make sure everything works. So, easiest way to do this is grab your structure that you have here. Now I already have our gauges homed and positioned. All we're going to do is just give you a bit of a demo of what's going on. With our shield plugged in the back, that's your standby controller. A trick with this is you cannot upload to the Arduino when you have it plugged into the shield. And it's got to do with the wiring, it's got to do with how the different pinouts were done with serial interrupts and all that. So a little bit frustrating, but if you just take the code, it's going to work. So you only have to do this as many times as you upload to calibrate and then do your final upload. But upload everything when it's off the shield, and then when you're ready, plug it into the shield. And you will need 5-volt external power coming from the ABSIS bus as well to drive these zeroing units. So let's go and plug this into the shield. There we go. Lovely. And I'm just going to leave it dangling there. It's easier for me to operate it and it's going to be nice and like dexterous. You don't want it screwed in there and trying to operate, it just gets real clunky. Same with these, as well as when you install it at the end, always install your altimeter last. That way you've got nice, easy access to that circuit board behind. So let's go and upload this code, and then we are going to install it into the back of our shield. Beautiful, done uploading. Then we're going to grab it and we're going to open up our serial monitor. We're going to look for a message that says calibrating steps per revolution, and then it's going to go and do 1 full rotation until it hits the zeroing sensor, and then it starts the count. Now I'm going to fast forward this. It takes about 4 minutes to do the whole process, maybe a little bit less. It is quite slow because I want it to be accurate, not fast. And you can see that little needle moving behind there, and our optical sensor is on the left here. Here we go, it's passing through it. It's triggered it, so first 0 detected, now it starts the count. I'm looking for about 720 steps. It's got half micro stepping, so it's 2 steps per degree essentially. And if it's different to 720, I know that it's either lagging a little bit because there could just be a little bit of debris in the system. So we're just looking for a reasonable amount. 720 is perfect. These two on the left are showing 720. Let's have a look to see what this one gives us. Beautiful. Locked in place, we're showing 751. So that's quite a little bit out. What I'm expecting that to be from is these displays have little surface mounted components on the bottom. I'm just gonna tweak them out. They probably pushed a little bit on that needle and that's what's causing it. But 751, not too big of an issue because the nice thing is every time we're rerunning this code, it's gonna self-update itself. And later down the track, I'll just create a self-calibration for steps per revolution. So every time it's doing it, it's always updating that value, no matter how stuck it's getting. So now we want to go and grab our gauge face, and this is the one here, and it's got 2 cutouts for these displays to shine through. Now, we engrave first, then we cut, and it leaves a white edge. I don't want that white edge showing within these windows, so I'll show you what I did. I turned it on its back, I got my airbrush, and pushing it firmly on a piece of paper towel to mask it, I then just encolored in those edges. Now, with that done, we can take away this paper. There we go. The power connected to the stepper motor is locking it into that position as if it was up against a mechanical stop. It's pretty hard to move a stepper if power is being applied to those pins. Now I'm gonna push this up against it. I'm gonna let it push those displays into their final position. Then I'm gonna go align it. This is as good as it's ever going to get. These don't have to be perfect because we can always micro adjust it in the code, which is nice. And then that should work well. Then with that there, we're going to go grab our needle, and I have homed this to the 100-foot indicator. And I'll tell you about that now. Wrong way. Of course we installed it the wrong way. These needles are so damn thin. That there is pretty good. I'm happy with that. That's great. We're gonna grab our gauge face, our spacer, install it, and we're gonna sandwich together. There we go. And that there is going to sit nicely, ready for us to install the rest. I want to go and get our RWR. Let's move this out the way. And this is this beautiful instrument here. It's running a little 2.8-inch circular screen on the back, and I've gone and put vinyl reticle on the front. And I'll upload all these files so you can go get that reticle cut out. I did it on the Cricut, and then I used some transfer paper, and it looks pretty good. So what we're gonna do is we're gonna bring our instrument panel forward here, and then we are going to slot it through. There we go. Let's grab the sari. Now this sari looks like it's got a screen in it, but it's actually just painted green acrylic. And I'm not going to put a screen in that. I'm actually saving that for later, where Ben F111 or Ben from the F18 sim, he's building a real working 3D sari unit, and I'm saving it for that. I don't want to buy a screen to chuck it out later. I'm going to save it. So let's just pop this in as a nice placeholder. And again, we'll feed that wiring through. Alright, if we have a look here quick, you can see these knobs here, the push to cage, are text-filled white. Now, I did these by resin printing them. They've got a recessed text in them. I've gone and painted them with a primer to give it a nice smooth finish, and then I've hit it with some lusterless black or SMS camo black. I clear coated it with 2 or 3 coats really to protect it from just me using it, but using a clear coat allows me to use this technique. I go and grab some white Citadel paint, I water it out using a thin paintbrush, I use its capillary effect to dab it into the letters. Once it dries, I can then get a wet paintbrush and I can start wiping away that, rinse and repeat until you fill that area up. Then I go and apply a clear coat and then a matte coat on top of that. That's how I did all these knobs. It's a really nice way of doing it. There we go. Beautiful. Now I'm just going to go and wire these up at the back. They're pretty simple, and then we're going to install the altimeter. Alrighty, that is looking very nice. Everything is plugged in, everything is ready to go. Now what we can see here though is it's showing 150 feet. Now with the altimeter, it is a bit of a finicky gauge, but you're kind of pushing all that wiring in. There is chance of that needle, 1, moving, and 2, not aligning it properly, but that's no issue, because I'm going to show you how to perfectly calibrate it in the code coming up. But what I did was, just before coming to this section, I reran our calibration. This is pretty important for every gauge once you screw it in, but you want to make sure that in its screwed in position, it's going to do the full 360, there's going to be no fouling, it's looking good. And you can see we're showing 720 on the step count. That is perfect. 2 steps per degree for 360. So all that means was when we had it in the loose configuration, one of those little resistors or any surface mounted component, I think on the back of these displays, was just fouling that zeroing needle. But now it's all snug in there, it's looking good. So what we can do is we can go and open up Open Hornet Lower Instrument Standby Gauges version 3. Now that's going to be in the package as well. Now without getting stuck in the weeds of all this code, it's just code written by me to kind of suit the Open Hornet gauges, and I wanted to do it as a mental exercise. I'm sure Open Hornet in due course will write their own code for this, but this works pretty well. Now, what I was talking to you about before was if we scroll down and we go to lines 335 to 346, and this is where we're initializing the gauges, and we can put all the parameters in for what our gauge is showing. The first one I want to show you is gauge VVI, Vertical Velocity Indicator. We're showing the name, how many steps per 360, its home position relative to where step 0 would be. Now on the VVI, that's at -6,000. So that's the angular distance, it's 133.5. That's just where mine is homing at. And then I want it to be 170 degrees, which puts it to the 0. And then max and min travel, where the zeroing is it 0 bill? That's true or false. And then the pin count. And I've got BKA 30. Now this is my version of just fixing what the Open Hornet naming convention error is. Have a look. If yours doesn't work nicely with BKA 30, type in vid-29, capital letters VID-29, see if that works for you. I've put 2 lots of code in there to see which one works best. Now you'll see uncomment below if you're using the Open Hornet VVI gauge face. Well, I've gone and created my own gauge face, which looks very similar to the Open Hornet one, but you can see that the -2000 and a couple of these numbers at the bottom are ever so slightly different. Open Hornet's made it off a version of a VVI that they've seen, and I've kind of replicated the DCS VVI. Why? It kind of made it a bit easier for the video for us to make sure that our angular and our linear extrapolation of it works. But hey, Open Hornet will do their own code for this. If you want to keep with that, go for it. If you want to make one of these in the package, just go and comment out which one you're not using. Now we spoke about our altimeter homing initially at 100 feet, and then it's going to initialize to 0 feet, but because of the way we screwed it in, it's gotten shifted to 150. So how do we change that? Well, we want to go to this figure here, which is 36.0. That is 36 degrees from its 0 point to the 100 foot marker. We want to go to the 150 foot mark now because I don't want to unscrew that to try and get it perfectly on 100. This is how you're going to calibrate, so it doesn't matter that you don't get it perfect. First we're going to do is update our caption, and we're going to go 150 feet, and 150 feet works out to be 54 degrees. How did I work that out? I went onto Fusion, I measured the angle between the two, zooming in, it shows 54 degrees. There we go. So we're going to type in 54, and that is it. Cool. And that's about it. It shows the rest of the code here. Have a look at it if you want to try debug it. If you want to try understand it, go ahead. I won't get too stuck in the details, but I will show you this one last bit. The rotary encoder for the standby ELT, which is our pressure gauge, and the rotary encoder for our SARI, which is this one here, push to cage, I've gone and changed these values from their default 3200. I found that the increments were just too big, and it's changing that number between 0 and 65355. It's changing it in 3200 increments, and I just found it was too coarse. So go and change these how you will. I've gone and taken the SARI to 16. It kind of looks a bit more closer to DCS, and then the standby press ELT, and I've changed that to -600 and +600. That way it's a real fine gradient that it's shifting up on, and it's closer to what DCS replicates. That way they 1-for-1. 3200 was just too coarse and was kind of changing it 2 pressure increments per click on the rotary encoder, and it just wasn't nice. So tweak with those, see how you find out. And if you find that you've got a different setting, let me know in the comments, and I'll be more than happy to give it a go. But that's the code. Give it an upload. I won't go into what the tabs are. We can do that later as an advanced Arduino lesson. So all we've got to do now is disconnect from our shield, and then we can go and upload it. That's pretty cool. And we have a really nice stripe pattern there, which shows that the ultimate is below 10,000 feet. That's all in there. Now, a little nice thing about this code that I wrote, when you're in the game, let's say your standby instruments aren't doing what you want them to do, they've gone completely out of calibration. If you press and hold the test button for more than 5 seconds, it's going to go into a test parameter. DCS BIOS will still run, it's just going to rehome all your gauges, it's going to change the LED lighting on them, and it's going to then, when it's all done, it's going to zero them and then re-put them back to where the game is, just in case they go out of whack for some reason. But that's looking pretty cool. So let's get into DCS, load up DCS BIOS, the serial monitor in the back, and I'll show you once we're in game. Now, while the game's loading up, I actually better show you something, because if you're not following along in the series, you're not going to know how to do this. I'm going to give you a quick 30-second to a minute introduction on how to do this. But if you want to know how to set up the RWR, go to episode 21, and I think it's episode 26. It's the AMPCD and the IFE episode. They're going to teach you how to do all of this. But you want to go into your DCS world where you've installed it. You want to go into mods. You want to go aircraft. You want to go F18, cockpit, scripts, TEWS. It's where the RWR is stored, indicator, and RWR and net. And we're going to open this one up. We are going to add this line at the bottom on line 79 through to 81. No, we don't want to update. And this is just going to create a user export. Now, unfortunately, in some servers, it will kick you out as not a pure client, because DCS does not allow us to export files, which is the most annoying thing in the world. Maybe we should create a global petition to get ED to fix this. Now, this is RWR. We've named it RWR, and we're going to put that into our monitor config. Again, episode 21, episode 26, I think it is, will teach you how to do that. But scroll up to the top here, and we are going to want to change the shader line defaults in these two purposes to these numbers in orange. The green is the original. I've just commented them with 2 hyphens just so I can keep them, but we want to change them to these. The reason for that is, in game, if you don't change these, it will look good, but on our export, it will look bad. It will look very fuzzy, and you're not going to get a nice indication. You need to really reduce the thickness and the fuzziness of the text that's exporting to get it to show up nicely here. The downside is it affects the in-game view. So pick which one you want to use, but that is what you're going to use here. If you're seeing on your export, it is too fuzzy. Then we're going to go to our usual cockpit mod, which is under our DCS folder here. It goes DCS config monitor setup, and that's where we created Scott's cockpit, or whatever you've called yours. And I've just gone and added it here because I don't have these connected at the moment. But our RWR, for your purpose, it is going to start at 10 pixels below your monitor height if you're using the same monitor as me, and 480 works really well for width and height. And we're going to press save on all of those, and we are going to go into DCS. If you don't have it already, you're going to go change your resolution. Episode 21, episode 26 is going to show you this, and we're going to select our monitor preset, and then we're going to launch into it. The game loaded up. The best way to test this, if you want to just test your RWRs working and also your gauges, you get an all-in-one package. If you go mission, F18, and then you go mission practice, defensive systems, it's got some SA15s and SA8s that will show up on this. It's probably the best way to do it. Then we're going to go, okay. That is looking good. And you can see the N or the north indicator on our RWR is showing up, but we're not showing any DCS BIOS indications because we got to open up the Connect serial port. So to do that, we're going to go and open up our folder, local disk C, Scott, saved games. Now, if you've seen other episodes, you know how to create the shortcut for this, but for those joining us for the first time, go DCS save games, scripts, Arduino tools, and we want to click the Connect serial port. Now, episode 12 shows you how to do this if you have multiple Arduinos. I'm just using the singular serial port just because I've only got one connected at the moment. Click that, it's on COM3. Here, resume. There we go, those gauges come to life. I'm using a keyboard. Let's duck down quickly. Let's get away from the RWR, because that way we can just talk about what we're seeing. We're looking at a nice unwinding altimeter gauge. We're showing good calibration there. Nice speed. Beautiful. Now I'm gonna try evade an SA15 or 8 just using keyboard. So let's give this a go. Let's climb up into it. Let's turn towards where I know the threats are. Now that is just the nicest looking altimeter. Now you'll see it lagging a little bit as it passes through that homing point. And the reason is Arduino isn't the fastest processor. I'd ideally like to put some drivers behind these steppers so they just become smooth. Got the 15 and 8. There we go, the 8's now looking at us. Let's see if we can get it to launch. There we go. That's launching on us. Let's go pull up. We can see it trailing there. Keyboard and mouse doesn't quite do it, hey? Hey, but that's okay. That is looking really nice. It's still unwinding. Let's just go press escape and let's go restart. And I want to show you how these altimeter gauges work. Alrighty, let's get out of the SA15's area. Let's go all the way down and let's see how this goes. Probably not the best mission to be testing and troubleshooting, but hey, let's give it a good go. So we're looking at 900 feet, so about 500 foot out. Let's run the test program to see if it's a needle issue or it's BIOS. So we're going to press and hold. It goes red to show that we're in the test function now. So our airspeed's great. Altimeter looks to be about 500 out. Okay, so we're meant to be at 700, it's showing 200. Everything else is working. The 13's looking at us. So what we're seeing is, let's just give this a pause here. What we're seeing is that our needle, which is our front needle, has gone out of calibration. Or the back one, but I'm assuming it's the front. And the reason for that is I think there's an ever so slight bend in that needle and it would have just caught on the gauge face when it was spinning rapidly and it's just pulled it out of calibration. I'm going to deconstruct this later and I might just put an ever so spot of glue on the needle front. I don't want to though, because I don't like putting glue around stepper motors, but we'll have a look at that. But if we just go here, resume, before that 13 gets us, we can see that that altimeter looks quite nice and the 13 got us. But that is about it. Let's get out of that. That is the lesson. It looks awesome. Once we fix this altimeter's front needle, and it's just probably it's not snug, and I've put it on and off so many times trying to do this video, that's probably what it is. I might just create a new one, give that a test. But you can see these two, which I put on once, never touched again, they're perfect. They really are quite nice. So go take what you've learned today, give it your best go, show me what your standby instruments look like. Now, remembering for those that watched other episodes, the SARI, if you want it to be a screen, you're going to have to do it through Helios. I'm not a massive fan of Helios, so I'm waiting for something pretty special. I'm waiting for the full functional SARI made by Ben F111 or Ben from F18 Sim. He is busy working on version 2 and it looks damn good. I saw it the other day and I'm quite impressed. So yeah, it's good to be making content again. Go enjoy some flying, enjoy your week ahead. I will see you in the next episode. Let's hope it doesn't take so long to get another one out. I'm gonna go install this. Once that's all fixed up, I'm gonna fix the code. One more episode for the lower instrument panel, then we start with the upper, then the sides, then the seat, and then we are all done. So go enjoy your weekend, go enjoy some flight simming, and I'll see you in the next episode.